Hey there guys, today we'll be doing an example of mesh analysis. I've picked this circuit for my example as it contains current sources. It is possible that it sometimes confuses people when there's current sources present in a circuit. Just in case that you don't know, mesh analysis is a circuit analysis technique which is used to find the voltage drops and the currents in a circuit that is a little bit more complicated, such as this circuit. So let's get to it. Step 1 is label your meshes. Alright, so here we have the first mesh. I'm going to label this as I1. Here's the second mesh. Going to label this as I2. Here's a third mesh. Label this as I3. And label this as I4. Okay, now the step 2. Just to say, I always like to label my meshes going clockwise. You can also label them going anti-clockwise, but make sure you label them all consistently. KVL on meshes. So what you want to do is you want to apply Kirchhoff's voltage law on each mesh. Just in case that you don't know, Kirchhoff's voltage law states that the sum of all the voltages in a loop always adds up to 0. This just means that if there's a voltage source and there's a resistor, we know that the voltage source creates some amount of voltage and the resistor must drop that voltage. That's why the sum of the voltages is 0. Alright, so let's start with here loop 1. Here we can see that we can just substitute I1 as 9 amps because we know that 9 amps is what is flowing in the circuit. Also, we don't actually know the voltage drop over this 9 amp source. So we will just say that we will just label this as S. But we will label this as negative S because this is a source. As you can see, current is coming out of the source. So it's actually negative S. I like to label my sources with a sign of negative, and I like to label my power sinks, such as resistors, with a negative sign. So the current comes out and then we're going around in this mesh. Then we hit this 100 ohm resistor, which is a sink. And the current going through this 100 ohm resistor is not just I1, it is actually I1 minus I2 because I2 will counteract that current going down. So I1 is 9 amps and then I will write I2. And obviously the sum of that is 0. So that's loop 1. Done. Now let's go to loop 2. So the first thing is the 10 ohm. And what's the current going into the 10 ohm? It's just I2. It's not being counteracted by anything. Then we have another 10 ohm. Now this 10 ohm is being counteracted by I3. So it's I2 minus I3. I always like to write the current first for the loop that I'm in. So in this case, I'm in loop I2, so I always write I2 first. And then I write minus the counteracting current. Now the next thing is this voltage source. As you can see, the current is actually going into the voltage source. This means the voltage source is actually acting as a voltage sink. So I will write this as positive 10. And then we'll come back here and then we'll be back to on the 100 ohm. And the current will be I2 minus I1. And we know I1 is just 9 amps. And the sum is 0. Now loop 3. Okay. So the same thing, 10 ohms. this time I3. Then we have the 10 amps. Now the current is again coming out of it. So that means we'll model this as a source again. So we'll put a negative and we'll just say the voltage drop over this 10 amp current source is G. Like so. And then we have the 10 volt. Now the current is actually going into the negative terminal of this voltage source. That means it's actually a power source. So I will write that as a negative 10. And then the resistor, obviously 10 I3 minus I2. Is equal to 0. That's loop 3 for us. Now the last loop. Okay, so let's start with the 10 ohm resistor. The current through that is I4, going through I4. Then we have another 10 ohm resistor here, which is also again I4, not being counteracted by any other current. Then we have a voltage source. The current is going into the positive terminal, which means this voltage source actually is acting as a power sink. So we'll have to write +5, and then we'll come back to the current source. Now the current is actually going into the current source, isn't it? So that means it's actually acting as a power sink now. So we'll actually write plus, and we labeled it as G, the voltage drop over that current source. So we'll just put G again, and then is equal to 0. Okay, now we have these system of equations. We have 1, 2, 3, 4 equations here. Okay, so as we can see here, we actually have, let's count the number of unknowns that we have. We have I2, we have I3, we have G, we have I4, and we have S. So if we count the number of unknowns, we actually have 5 unknowns. And we only have 4 equations. This means that we won't actually be able to solve for all the variables. This means that we need also another equation. We can get our last equation by applying KCL at this node. Let's call this node A. Now we're just going to draw this node here again. So as we can see, the current going down is 10 amps here. And from here we have I4 coming, as you can see I4 here. And what's coming out is I3. So we can say that 10 amps plus I4 is I3. Alright, and that will be our 5th equation. So this is our equation 1, equation 2, equation 3, and equation 4. Okay, so the next thing to do is to solve this system of equations to calculate our variables. So I've just opened up Wolfram Alpha here that can solve simultaneous equations. So now we just put our equations in. Also, I will substitute I2 as B, I3 as C, and I4 as D, because Wolfram Alpha doesn't take I2, I3, I4 doesn't like it. So the first equation is loop 1, negative S plus 100, 9 minus B is equal to 0, and you just separate the equations by commas. Plus 10, B minus C plus 10 plus 100, B minus 9 is equal to 0, 10 C minus G minus 10 plus 10 C minus B is equal to 0. and then 10 D plus 10D plus 5 plus G is equal to 0. And let's not forget our last equation, which is a Kirchhoff current law, is 10 plus D is equal to C. Let's calculate that. Yeah, we'll just click the approximate form button, and here are our answers. So B, C, D, G, and S. Alright, so here I've just written down all the values again from here, Wolfram alpha. So I2 is 8 amps, I3 is 7.21 amps, I4 is negative 2.87 amps. So the negative number just states that how we defined our direction of current. For example, I4, we define it as going clockwise. The negative just tells us that it is actually going anti-clockwise. The voltage drop over G is 52.447 volts, and the voltage drop over the solar panel is 98.936 volts. Thank you. Alright, that's the video. If you have any questions, leave it in the comment section, and like, subscribe, and share if you liked the video.